So let's just define the variation in capital stock as investment minus the depreciation of the previous capital. Remember that investment is just the savings rate times output. So if we take the capital level at period t over there, we will get that capital period t plus 1 is equal to the capital at t minus how much this capital at t depreciates plus investment. And if we define the growth rate of technology by G and the growth rate of population, or in this case the labor force, as N, then technology at t plus 1 will just be equal to technology at t times 1 plus t, and the same for labor. So let's introduce the concept of steady state. The steady state is a point where this artificial capital over effective labor is not growing. Its variation is equal to 0. It doesn't change. Now we want to know what this variation in the small k, capital over effective labor, is equal to. So we take the variation of capital, which we know is just equal to investment, S times the production function, minus the depreciation of the old capital over effective labor level. And then we have to subtract the growth rate of this, well, its variation. So we subtract the growth rate of technology and the growth rate of population and labor times capital over effective labor. Now, since this, and this is the same, we can simplify and say that the variation of capital over effective labor is equal to investment minus depreciation plus the growth rate of A plus N, all that times capital over effective labor. And all that, if we are at a steady state, is got to be equal to 0. In other words, this investment, actual investment, has to be equal to this, which is the break-even investment. You have to invest at least this in order for your capital stock not to decrease. If you're wondering why do we introduce this and this, just look at the capital over effective labor. If technology increases or if labor increases, then this whole ratio will decrease. And that is why they have a negative sign here. So we already know how our intensive form production function looks like, and we know that since the savings rate is got to be between 0 and 1, that will just be a fraction of this production function, and it will look like this. But break-even investment is just the equation of a line with the intercept at 0, and with this whole thing as the slope. So that is break-even investment, and the point where break-even investment is equal to actual investment is this one right here. So for this level of savings, there is only one steady state level of capital per effective labor, which we call K star, and one level of output per effective labor, which we call Y star, because we are at a steady state. But actually, we could change this. We could change the savings rate. We could make it bigger, smaller, and this will just shift the actual investment curve up and down. So we find that there are infinitely many steady state equilibria along this break-even line, depending on the savings rate. And whenever we reach one of these guys, the economy will stay there. Because at this point, at the steady state, this is not growing. So remember, at the steady state level where capital is K asterisk, then we have that this will be the break-even investment and also the actual investment, and the difference between investment and output will actually be just consumption over effective labor. So these will be investment and these will be consumption at a steady state.